Yes, G1 belongs to the subgroup generated by U and P1, and we have this unique expression, U to the I, P1, U to the I equal to G1. Remember the same I, again we can decide in the same permutation whether or not G2 belongs to the subgroup generated by U and P2. And UI, P2, U to the I is G2, etc. Yes? So we have to do this. These two conditions must hold for I going from 1 to R in the same permutation. Right? So the key is that if no, if in the first case no, G1 does not belong to the subgroup generated by U and P1, then we go to case 2. Right? So we repeat the same thing again for each of the factors 1 to R. So if anytime there is a no, given Gk does not belong to the subgroup generated by U and Pk, for k greater than 1 or equal to 1 or less than R, or the value of I is not the same as before in the same permutation, yes, then we can say that G is not conjugate to P. So you see how this algorithm goes. You take the first permutation. If G belongs to the subgroup generated by U and P1, and we have this U to the I, P1, U to the negative I, P1, U to the I is equal to G1, continue the next one. Is G2 belong to the subgroup generated by U and P2? If it does, and the word satisfy U to the I, P2, U to the negative I, P2, U to the I is equal to G2. Continue that process until the last part of the word, R. And if it does, then by Magnus, G is conjugate to P. If the first case fails, G does not belong to the subgroup, then there's no use continue. We can go to the next commutation. And if this procedure continues, so if there's any disruption of any one of these, that the subgroup generated by Gk does not belong to the subgroup generated by U and Pk for any of the value k from 1 to R, or the I is not the same, then we say that G is not conjugate to P. So what is the latest? So the final decision will be reached by the R running of the process, yes? That is the first one, at least the latest, yes? If it occurs in the first case, it's conjugate, then we stop. The algorithm stops. If it's not, G1, for example, is not in the subgroup generated by U and P1, we go to the next until we check all the R permutations. Yes. Any questions?
I have questions, Anthony. So, can we go back to the slide where you showed Gilbert's theorem again?
Sure.
It's way at the beginning. And I'm sorry to...
individually many values?
No. I'll see.
You can decide.
About that
proposition.
Okay.
This
So this first one.
one.
So, now, you said that in your case, when A is free abelian on 2 generators, you also get that this generalized free product is a subgroup of...
No, I showed that. I didn't show that. I showed the result of the first case that if F is a free group, U belongs to F, A is a free abelian group on rank 2, F is a free abelian group of rank 2, and U generates its own centralized that, then the group G is residue free.
Is it also the case that it's a subgroup of the Cartesian product of isomorphic copies of F in that case?
I didn't check, but I assume that since that is a result.
In that case, so what's the input to your algorithm exactly? The input to your algorithm is 2 words, or is it
2 elements in G?
Okay.
Yeah.
Because it seems like in this case, in the direct product, so in the case when A is free abelian of rank 2. Your generalized free product is a subgroup of the Cartesian product of how many isomorphic copies of F?
That is not necessary.
That is not. I didn't use that part there. I just used the first premise of his theorem. Yeah.
Well, maybe we should take this conversation offline. But I mean, I'm wondering. It seems to me that we could solve the conjugacy problem in the direct product of copies of F in a straightforward way.
As a result of this theorem?
Well, in general. So if you have a direct product of copies of F, I think, I'm not sure that we could solve the conjugacy problem.
But for that you would need some control over the set of free groups that you are having there as the components of the direct product. And I'm not sure that that is controlled by the statements.
Yeah, that's what I'm asking about.
Yes, I understand you.
Yeah.
Right.
And that, because that would influence your algorithmic approach.
Yeah, but you see...
That you want to
as
an alternative.
Yeah. Because see, it sounds like, Anthony, there's always this question about exactly what's the input to your algorithm. If the algorithm is hardwired for your specific group, and the only input is your 2 words, then you get to assume the world. You get to assume that you have this description, any old description you want of your group. You get to kind of assume you have it in hand. For example, if it's a subgroup of a direct product of free groups, you get to assume that you've got that there in your black box.
But the key here is this: the fact that U generalized is one centralized, that U does not only commutes with itself.
That's fine. That's fine. You get to assume all of that.
Also,
that's
what we need to be able to solve the generalized word problem.
Yeah.
That is, and we need to be able to write the words in a unique way.
For your algorithm.
Yeah.
But, I mean, I was suggesting there's another approach.
Well, I see.
That might be.
Right. Well, that's not a criticism.
Yeah.
We're just talking, yeah.
Right. So what is the approach? Because I couldn't see any, well, this is just one way, but I don't know how else you can do it. So you're suggesting...
I'm suggesting this. And I don't know, this is not my area, this is a naive approach, perhaps, okay? But it seems to me that another possible approach is if, in fact, G is a subgroup of the direct product of isomorphic copies of F. See, in that...
this F?
This free group, this free group. So you have if you have a group that's a direct product of free groups, I think we could construct a very straightforward, I'm not sure, but I think in the direct product case you can construct an easy algorithm for conjugacy. So that would be another approach.
I think there was a...
opinion again.
Yeah.
And that is that his case tries to handle the free group of rank 2.
The abelian group of rank 2. Oh, the free group of rank 2.
The free group of rank 2.
Yeah.
Which brings in another complication, if you want to consider it complication, because that contains all the other free groups.
That's okay though. He's saying, I mean, we can solve conjugacy in the free group of rank 2.
Sure, but the question is that when you are forming, so it is a different knowledge to just know that you are working in a free group somewhere and that you are working with a direct component of free groups of a known type, I think. Because it's because of the conjugacy being so complicated, and that bridging process, I think, is influenced.
Yeah, I think there is something, I'm not sure, but if we have
that doesn't mean we don't have an alternative here. Yeah.
I think there's a theorem that says that if we have a direct product of 2 free group, F1 and F2, and the conjugacy problem is solvable, but the subgroup, if we take a subgroup, it's not, or something like that. It's kind of using direct product.
That's true. That's
changes,
true. That's true. Subgroups. That's true.
Yeah.
So
how can that be? Yes.
take
Right.
the direct product of free groups actually yields a group without, what is it, membership problems.
Yeah.
Yes.
Right,
That's
yes,
where
correct,
that is-
correct. That's
that
where it,
is
yes,
so
that's
That
where
is
it
the
comes
theory
from.
that you're referring
Yeah.
Correct, which means, yeah.
Yeah.
But I also believe that a variation on that lemma would be an interesting thing to consider.
But notice it was kind of difficult to kind of go through, notice how many theorems I have to go through to kind of get this to build it in a certain way.
That's why
Which-
Gretchen is thinking of an alternative.
Right? And the kind of algorithm is specific, right? Because it's using whether or not these elements falls in the respective subgroups.
Yeah, you're
So
using
it's-
its structure as an amalgamated
Yeah,
product. I'm
correct.
thinking, could you have used its structure as a
As a-
subgroup of a direct product
I see,
instead?
I see.
And that might be making it harder because there is a crucial influence of the knowledge about when elements are commuting
Yeah.
in the amalgam.
Right, so how would you know that, for example, what subgroup would you take, one amalgam, for example, in the direct product? Would elements commute there? Because if the elements do not commute, how would you get like a cancellation in terms of words?
And also, if U doesn't generate its own centralized, things become much
Yeah,
more difficult.
difficult,
It depends
yes.
on the amalgam.
So that's what the kind of
Really
key
basis
input here.
Yeah.
element, yeah.
You see, the subgroup is some power of U, and U generates its own centralizer. So when you take factors from different parts, F and A, they do not commute.
Yeah, but Gretchen's idea goes along with what Ben was suggesting too, that the residually free groups are really direct subgroups of the direct products or copies of.
Yeah.
So yeah, so one question Ben said was, how can I improve this? He says that if you take rank 1 or extensions of free groups.
That's the more general
If we
regional
can,
extension.
so in other words, instead of using a free group, he says maybe if I try for a fully residually free group, if it's going to work. And I think so. I think everything is satisfied because we have the solution to the generalized problem. You can check.
And that's the Lindenau-Schupp approach.
So we can do it for
Trying to balance
an
the work
extension,
between
yes, the free
regional extensions and
by rank n, I suppose. But I have to think of it some more,
but
whether or
that's
not
going in the
to make sure that
direction of
nothing is
generalized
violated.
listing.
Yeah.
Instead of finding an alternative, and your point of view might come handy at the generalization step too,
Possibly,
because you are asking for the direct product.
yeah.
And I want to thank Kathy for helping me edit this, because sometimes I had different
Yes.
statements, and she said, well, this is not clear, you know, and so she did. I want to thank her for that as well. The expression, the way I expressed
By the way, your talk was very nice. Yeah.
I want to thank Kathy for coming today.
Thank you for everything.